Convex mirrors. Okay, so here's an example of some ray diagrams or ray tracings with convex mirrors. First of all, when you're drawing a convex mirror, you have a principal axis, and the mirror is opposite of a concave mirror, like so. Again, imagine that if this were a circle, then the center of the circle would be about right here. And we would give a letter C there for the center of curvature. And from the center of curvature to the outside of the mirror is the radius of curvature, what I'm calling small r. Halfway from the center of curvature to the outside of the mirror is the focal point. And the distance from the focal point to the outside of the mirror, that's the focal length, or small f here. Okay, now if we have an object, this would be to the left of the mirror, O for object. Then the distance of my object to the mirror, that's still my D sub O. And where would the image form? Is it upright or inverted? Is it enlarged or is it reduced? And we're going to use some rays to determine where the image forms. And so the first ray I'll use with the color black. The first ray comes off of the object because that's where the light comes from, on the left side of the mirror or the front of the mirror. And it comes off the object horizontal, and when it reflects, the back tracing of the reflected light goes through the focal point, which is now to the right side of the mirror or behind the mirror. So what I will have is, this is a back tracing, it's a dashed line here, and the reflected ray actually comes off of that. So that's my reflected ray, or what I call ray number 1. The second ray that I'm going to draw with purple goes from the object and travels as if it were going to go through the focal point. Of course, it can't go through the mirror to the focal point, but if it were to go to the focal point, it would keep going through the mirror at this point. And then the reflected ray goes off horizontal. So this is ray number 2. And it's the back tracing of the reflected ray, or the horizontal ray, that I'm interested in for inside the mirror, because it's where these back tracings intersect. That's where your image is going to form. Now the last ray, which I will use with the color orange, goes from the object to the center of curvature. So it comes off of the object as if it were to go through the center of curvature, like so. And it reflects back on itself, and we call that ray number 3. Yeah. And so the image forms where these back tracings intersect. So my image in brown is right at that point. And my image, as you can see, it is upright. The size is reduced, but it's also on the right side of the mirror or behind the mirror, so we say that the image is virtual. Now there are some sign conventions when we're talking about the distance of the object and the distance of the image and the focal length. All of these depend on whether or not you're in front of the mirror or the left side of the mirror, or on the right side of the mirror or behind the mirror. And so I wanted to go ahead and write this out for you. So if your object is on the left side of the mirror, we give the D sub O a positive value. If the image forms on the left side of the mirror or front of the mirror, we also give a plus value for that. And if the focal length is on the left side of the mirror, in front of the mirror, we give a plus for that. Now, if the distance of the image is on the left side of the mirror or in front of the mirror, we say the image is real. And if the focal length is on the left side of the mirror and therefore positive, we say we're dealing with a concave mirror. On the right side of the mirror, if the object is behind the mirror, we give it a negative value. If the image is behind the mirror on the right side of the mirror, we give that distance a negative value. And if the focal length is behind the mirror on the right side, that has a negative. If the image has a negative value, meaning the distance is on the right side, we say the object is virtual. No light is passing through that. And if it's the focal length is on the right side of the mirror, we say we are dealing with a convex mirror. Now, if the height of the image is positive, we say that it is upright. If that is negative, we say that it is inverted or upside down. And the height of the object, it's always going to be positive or upright. Now for your magnification, if it is larger than 1, we say that the image is enlarged. And if the magnification is less than 1, we say that the image is reduced in size. Reduced. All right, let's do an example. Okay, so we have a mirror, and the radius of curvature is negative 16 meters. The focal length, which is half of the radius of curvature, is the negative 8 meters. And the object is 10 meters from the mirror, which would be on the left side of the mirror. Notice that my radius of curvature is negative, and my focal length is negative. Therefore, I'm dealing with a convex mirror. So what I would like you to find is what is the distance of the image, or where does the image form, and what is the magnification or the size of the image. So we will be using the mirror equation for part A to find d sub I, and we will be using the magnification equation for part B. So using the mirror equation, we have a distance of the image that is negative 4.4 meters. That negative meaning that the image is behind the mirror, or to the right side of the mirror. I'll say right side here. So for part B, when we're solving for magnification, we see we get a value of plus 0.44. So the plus tells us that our object is upright. And the fact that our magnification is less than 1 tells us that our image is reduced, actually reduced to less than half of the size. And just want to repeat that because my magnification is positive, my image is upright. Okay, here's your practice, page 659, numbers 9 and 13. So this will be due our next class meeting, which is tomorrow.